Today we're going to be talking about section 3.6, converting measures. I know you've talked about some converting measures or measurements in science class in 6th grade. We're going to go a little bit more in depth with converting them. The U.S. customary system is a system of measurement that contains units for length, capacity, and weight. The metric system is a decimal system of measurement based on powers of 10 that contains units for length, capacity, and mass. Example 1. If we were asked to convert measures within the same system, so that would be within the U.S. customary system or within the metric system. We are asked to convert 36 quarts to gallons, and we need to know some important information in order to do this conversion. We need to know that 1 gallon equals 4 quarts, or that 1/4 of a gallon equals 1 quart. These are unit rates. Notice that 1 gallon, 1 tells us this is a unit rate, a comparison with one quantity being 1. We can use either of these unit rates to find an equivalent rate with 36 quarts. So for method 1, I'm using a ratio table. Notice that I have my labels set up, quarts versus gallons. I'm using this comparison that 1 gallon and 4 quarts are equivalent to each other. And then in the problem, we are converting 36 quarts. So you'll see that I multiplied 4 by 9 to get 36. So we do the same thing to the gallons. And we get our answer of 9 gallons. You can also use this unit rate, which I'm going to show you, 1/4 of a gallon to 1 quart. I'll show you that example. So same thing, we have our label set up in our ratio table. We've got that 1/4 gallons is the same as 1 quart, and we are changing the 1 quart into 36. Okay, and we do that by multiplying by 36, so we do the same thing to the numerator, and we still get the same answer of 9 gallons. What if we were converting measures between systems? We're asked to convert 10 meters to feet. So we know that because 1 meter is approximately 3.28 feet or 3 28/100 feet, that there are about 3 28/100 feet per meter. Because 1 foot is approximately 3/10 of a meter, you can also use that 3/10 of a meter per foot as a unit rate as well. So I show you both methods. Here we have feet and meters being compared, and we have our unit rate, and we're trying to get 10 meters. So we multiply by 10. We have the other unit rate set up here. We're trying to get to 10. So what we did is we converted the 0.3 or 3/10 into 1 meter by dividing by 3/10. And we do that down here. And then we multiply by 10 and multiply by 10. Now you'll notice that this method is a bit more complicated than this method. So you want to look at which unit rate would be more effective for you. Okay, so the answer for this method is 32 8/10 feet, and for this one is 33 33/100 feet. Now, just so you know, the reason that they're slightly different is because this squiggly line that we see up here tells us that 1 foot is approximately 0.3, and this is approximately 3 28/100. That means that they're rounded slightly, so our numbers are going to be a bit different when we use each of those to solve. Another way to convert units of measure is to multiply by one or more conversion factors. So this is a different strategy that does not use ratio tables. A conversion factor is a rate in which the two quantities are equal. When using conversion factors, write rates using fraction notation. So for example, we all know that 1 foot equals 12 inches. So we can write that as 1 foot over 12 inches or 12 inches over 1 foot. These are the same thing. Now remember that when a numerator equals a denominator, it means that this quantity is equal to 1. So even though we're using different numbers, because of the measurements that were given, the units were given, 1 foot and 12 inches are the same amount. So when one is a numerator and one is a denominator, it's going to equal 1. So that's going to help you for this next strategy. This next strategy requires unit analysis. You can use unit analysis, so we're going to analyze the units to decide which conversion factor will produce the appropriate units. You can cross out a unit that appears in both the numerator and denominator of a product. So basically, we are cross-canceling units is what that means. Let me show you an example. So if we wanted to convert 4 pounds to kilograms, we would write out 4 pounds. Okay, write out 4 pounds. And we're going to multiply it by the conversion factor that tells us how many pounds are equal to how many kilograms. This is the conversion factor that 1 pound is approximately 45 hundredths kilograms. And you can look these up online or they'll be provided, or it's ones that you'll actually know already, like 12 inches in 1 foot. And basically, I have an option of writing this in fraction form with 1 pound in the numerator, like this, or writing it with 1 pound in the denominator, like this. And I chose this, and here's why. In order to cross-cancel, there needs to be something in common in a numerator and denominator. So in this case, pounds was the common unit. So I want 1 in the numerator, which was the 4 pounds, which we started with, and the 1 pound in the denominator. You can cross those out and then just focus on multiplying across. 4 times 45 hundredths kilograms gives me 1.8 kilograms. And the denominators are just left with ones. So my answer is 1 8/10 kilograms. Let's look at another example of that. Converting 5 yards per second to yards per minute. So we're going to write out our starting piece, 5 yards per second. And I'm going to write it in fraction form because per means out of. So 5 yards out of 1 second, per 1 second. We're going to use a conversion factor to change our seconds from our starting amount to minutes. So we know that 60 seconds is the same as 1 minute. So I'm going to write this in fraction form so that the seconds is in the numerator because my seconds is in the denominator in my starting piece. That allows me to cross out the word seconds, so it will no longer appear in my answer. So 5 yards times 60 gives me 300 yards, and 1 times 1 minute gives me 1 minute. So my answer is 300 yards per minute. Okay, example 4. A runner's goal is to complete a mile in 4 minutes or less. The runner's speed is 20 feet per second. Does the runner meet the goal? If not, how much faster in feet per second must the runner be to meet the goal? Okay, to meet the goal, the runner must complete 1 mile in 4 minutes or less, and the minimum speed that's required is 1 mile per 4 minutes. So that's what that basically meant. That or less meant that's the minimum requirement. So basically, we're going to start with that amount in fraction form. I am going to use the 1 minute to 60 seconds comparison because I am trying to get minutes to seconds. So I have 1 minute in the numerator, 60 seconds in the denominator. That allows me to cross-cancel my minutes unit. And then I also have to use 1 mile to 5,280 feet as a conversion factor because I'm trying to change miles to feet. And I'm going to put the 5,280 feet in the numerator so that my miles can be cross-canceled. One is in the numerator, one is in the denominator. You multiply across. 1 times 1 times 5,280 and 4 times 60 times 1. And it simplifies to 22 feet per second. So the runner did not meet his goal because a speed of 20 feet per second is below the minimum speed of 22 feet per second. So unfortunately, that runner was 2 feet per second. That's how much he needed to speed up, 2 feet per second in order to meet his goal. And those are the notes for 3.6.